Here we have an exponential equation, and in this exponential equation, we have to solve for x. Okay, whenever I'm trying to solve for a variable that is in an exponential equation, so what I need to do is I have to get the same base on both sides of the equation. Once I get the same base on both sides of the equation, I can equate the exponents and I can solve for the variable. For example, if I have the base 8 on the left side and 16 on the right side, this 8 can be written as 2 cube and the 16 can be written as 2 to the 4th power, and we get the same base 2 on both sides of the equation, and we can equate the exponents and we can solve for the variable. But here I don't think I'll be able to get the same base on both sides of this equation, because here we have base 3 over 4 and here we have base 7 over 5. So we have fractional bases, and I don't think we'll be able to get the same base on both sides of this equation. So what should I do to solve this exponential equation? We have to use logarithm. So that is, we have to take either natural logarithm or common logarithm on both sides, and we have to solve this equation. So why should we use only natural logarithm or common logarithm? Because we'll be able to get values for natural logarithm or common logarithm using our regular calculator. So even we can take common logarithm. So because in all our calculators, I will be able to get values for common logarithm. Common logarithm is a logarithm with base 10. Okay, so before taking logarithm, first let's simplify the value of this fraction 3/4. So the value of, when I simplify this 3/4, it will become 0.75 to the power 7x negative 1. On the right side, when you divide 7 by 5, I'm getting 1.4 to the power 2x positive 5. Okay, now I'm going to take a common logarithm, that is logarithm with base 10 on both sides, that is log of 0.75 to the power 7x negative 1 and log of 1.4 to the power 2x positive 5. So here I have not mentioned the base for both the logarithm. Even if I don't mention the base for the logarithms, so everyone can understand it's a common logarithm. So that is with base 10. Okay, now on both sides I'm going to use the power rule of logarithm. That is, whenever the argument of a logarithm is exponential, the exponent we have in the argument can be moved in front of the logarithm, and it has to be multiplied by the logarithm. So now I can move this 7x negative 1 moved in front of the logarithm. So this is a power rule of logarithm. So then I'm getting 7x negative 1 times log of 0.75 equals to the same thing. I can move this exponent 2x positive 5 in front of the logarithm over here. Then I'm getting 2x positive 5 times log of 1.4. Okay, so 7x negative 1. So if I get value for this log 0.75 using calculator, I'm getting negative 0.125. Actually, this is not the exact value of this logarithm. So when I get the value of, when I take logarithm of this 0.75 using calculator, I have negative 0.12. It keeps going. So I just rounded to 3 decimal places over here, equals to 2x positive 5, and now I have to get logarithm of 1.4 using calculator. So when I take logarithm of 1.4, I'm getting the value 0.146, and also the same thing, it's not an exact value, so the value of log 1.4 has been rounded to 3 decimal places over here. Okay, now what I can do is I can distribute this negative 0.125 to this 7x. So when I distribute this negative 0.125 to the 7x, I have to multiply this 7 and negative 0.125. When I multiply them, I'm getting negative 0.875. Since we have x over here, that x should be taken over here. And negative times negative will become positive, and 0.125 times 1 is the same thing, that is 0.125. On the right side, so I have to distribute this 0.146 to this 2x. So when I do so, I'm getting 0.292x, and when I distribute this 0.146 to this 5, I'm getting 0.73. Okay, we are trying to solve for x, but the variable x appears on both sides of the equation. So either we have to get rid of the variable x on the left side or right side. So I'm trying to get rid of this variable on the left side because it contains a negative sign. So to get rid of this term, I have to add 0.875x to both sides. So I'm adding 0.875x to both sides. When I do so, this negative value, positive value will cancel out. I'm getting 0.125 on the left side. On the right side, when I combine this 0.292x and positive 0.875x, I am getting 1.167x positive 0.73. Okay, let me write the equation over here. 0.125 equals to 1.167x positive 0.73. Okay, to solve for x, I have to isolate x. That is, I have to get rid of all the values around the variable x. So let me subtract 0.73 from both sides. When I do so, this one will cancel out. When I simplify this one, that is 0.125, negative 0.73. I'm getting negative 0.605 equals to 1.167x. Okay, to solve for x, I have to divide both sides by 1.167. So when I divide 1.167 on both sides, this one will cancel out. So here we have a negative sign. And when I divide 0.605 by 1.167, I'm getting 0.518, and it keeps going. So if I round this value to the nearest hundredth, I'm getting negative 0.52 equals to x. I have solved for x in the given exponential equation. The value of x is negative 0.52.